good evening, and Happy New Year. I would have loved to give this presentation in person or I guess in live video call, but unfortunately, I was not able to as I'm in a different country and the time zones are very weird. But I'm glad that I can do it this way. Um, so my presentation is going to be on the Space Surveillance Network, or the SSN, and how they track space junk. So at the end of space missions, the satellites and the shuttles that come up have to come down. And oftentimes, they take a very long time to come down. They take up to 200 years before they re-enter the Earth's orbit for some of them, depending on how high above the Earth they are. And when they come back down, they don't come back down with all the material they went up with. They come down looking like the picture on the right. And the only material that is left is going to be the steel and glass that is not burnt off from the heat energy of the deceleration. So there's a lot of space junk created in those 200 years or so that the object is orbiting the Earth, and sometimes the shuttles and satellites can crash against each other and create small pieces. These pieces can be as small as 1 millimeter, which is 0.04 inches, and they can sometimes have speeds of 5 miles a second. And so the picture on the right is kind of an example of some of the damage that they can cause in the windows of space shuttles. So because the space junk can have such a negative impact on current space shuttles and space satellites, there is an international drive to kind of work on this problem. And sometimes in the International Space Station, when they have to redirect their locations in order to prevent collisions, there is international cooperation, and the astronauts can sometimes go aboard the vehicles of Russian or Italian or Chinese space shuttles. And the picture on the right is just an example of that international cooperation. Obviously, it is not in space, but the man on the medical man is a Russian and the astronaut is an American. And it's just an example of the international cooperation that's necessary in order to prevent the devastation that can be caused by collisions with space junk. So the Space Surveillance Network has the task of tracking these objects in space in order to prevent collisions and to kind of mitigate their effect. And their main jobs are to detect space junk, and then after they detect it, they catalog it, and they determine which country it comes from in order to put a label on it and kind of put responsibility on each piece of space junk. And when they have cataloged space junk, they make note of its position in space as well as its trajectory and when it will re-enter Earth. They have the capability of tracking space junk that is bigger than 10 centimeters. And compared to the sizes of space junk in the sky, this is kind of rather big for all that is possible. But 10 centimeters is about the size of a softball. And they're able to track space junk that's 10 centimeters when it's within the lower orbit range. That is about 2,000 kilometers from the Earth. Once you get to the geospatial region, where it's like 35,000 kilometers away from the Earth, the amount of space junk that they can track, or the size of space junk that they can track, is reduced because they need it to be at least a meter wide. And so there's a wide range of space junk that goes untracked. So now I'm going to move on to the more scientific part of this experiment, and I'm going to talk about the types of tracking devices. So there are two different classifications, but one classification is on the left. We have the dedicated devices, which are devices that the Space Surveillance Network either purchased or sent up into space for the express purpose of tracking. And then there's the controlled devices, which weren't primarily for tracking, but the Space Surveillance Network has control over and can take data from it in order to continue tracking the objects that it's cataloged. And there's the contributing devices. These are devices that the Space Surveillance Network doesn't really have control over, but they can borrow data from in order to continue to survey their space junk. And some of the other classification is obviously by device type, and there are many different device types, but I'm just going to talk about 3. The first is phase arrays radars, and so basically what these are is they send radar lasers into space, and it comes back, and when it hits space junk and comes back, it processes and kind of determines the location of various space junk. And these radars don't have any mechanical functions and are completely electronically controlled so that they can work very quickly, and they're capable of surveying a huge chunk of sky in less than half a second. And another type of sensor is the conventional sensor, and these sensors do have mechanical components, and they kind of shoot up heat and laser energy again to different satellites, and when the laser energy is coming back, it comes back with information about the satellite's trajectory. And a third type is the mid-course experiment satellite. This satellite has a lot of capabilities at recording various types of light. It goes from UV light to infrared light, and basically with these different types of light, it really is just capable of taking pictures and processing where the different objects in space are. So kind of trying to figure out how much all this costs, I found a quote from the U.S. General Accounting Office, and they said the Space Surveillance Network is composed of over 40 optical and radar sensors located worldwide and connected through 4 command and control facilities. It costs the Air Force about $60 million a year to operate the Space Surveillance Network. So clearly there is a lot going on, and that $60 million a year doesn't account for the 40 optical and radar sensors that were built. And so it costs a lot more than $60 million a year, but I couldn't necessarily find the cost of all the different ones. And so this is just a general estimate of how much it costs today. But it's kind of like the continued insurance payments for a very expensive car, because this was very expensive to put up and it's very expensive to maintain. So now I wanted to show you kind of a presentation of the data that this collects. So this video from the University of England uses the data from the Space Surveillance Network to kind of make a video of the progression of space junk throughout the years. So it's very cool, and I hope you enjoy. I might speed it up and make it a little bit faster. As you can see, the space junk very, very quickly increases. And now on Earth, we're basically covered in space junk from a very outside point of view. Thank you so much. I hope you enjoyed my presentation, and I will also send a list of the links that I cited as sort of my reference page, and a way for you to dig deeper if you're interested. Thank you.